Paris is renowned for its unbelievable metropolitan layout and imposing monuments, but what's often overlooked is that every corner of the city is a testament to its geological past. For instance, did you know that embedded in Notre Dame are actual fossils of ancient marine life? These tiny remnants reveal a fascinating story about what would one day serve as the foundation for the French capital. If you've already looked at Europe on Google Earth, I'm sure you're familiar with this image of metropolitan France, where the landscape as a whole seems fairly harmonious, but a geological map of the country offers a different perspective. Here we observe a variety of colors and symbols which indicate the age and type of rock at the surface, which we can group up into distinct geological provinces, among which the Great Parisian Basin. Spanning much of northern France, it is a broad depression in the Earth's crust made up of layers of different sedimentary rocks stacked from oldest to youngest, kind of like bowls piled into one another. And in the dead center of this basin, we'll find Paris, built on top of the youngest of these layers deposited during the early Cenozoic, about 56 to 30 million years ago. To understand how this basin first began to form, we have to go back over 200 million years ago, back to the Triassic, back when much of what is now northern France was intermittently submerged. Over time, as the continents drifted and the region slowly subsided, allowing the depression to deepen under its own weight, sediments continued to accumulate layer by layer, gradually forming the basin. Over time, the accumulation of dead marine life made up of the exoskeletons of microorganisms, especially of plankton like coccolithophores, led to the formation of limestone. This includes the famous Lutetia limestone, on top of which the city was built and from which many buildings are carved. The calcium carbonate found in the exoskeletons of these fossilized microorganisms is what gives Haussmann buildings their distinct white to beige hues, alongside other monuments like l'Arc de Triomphe or the Sacré Coeur. Because it's a sedimentary rock, limestone often preserves fossils, tiny snapshots of the ecosystems that once reigned of those prehistoric oceans. The marine origin of these building blocks are made even more apparent by traces of ancient marine life, like this fossilized sea snail found in one of the columns in Notre Dame de Paris. Building stones are heavy, and transporting them is a costly endeavor, which is why historic cities are generally constructed with the materials found directly beneath them. Early settlers took advantage of the readily available resources found near the surface, building structures that have stood the test of time. To this day, the Paris underground is still dominated by ancient limestone quarries, and some were even later converted into the infamous Paris catacombs. In fact, many geology manuals compare the Paris underground to a gruyere due to the voids left over from centuries of exploitation. Until now, we still haven't mapped the entirety of these galleries, which poses a problem to the stability of buildings standing over them. The traces left behind by the exploitation of the Paris underground are still very apparent. For example, this street in the southwest of Paris has sunk in, similarly to this Parisian courtyard in the center of Paris, due to the presence of ancient limestone quarries. Some of these quarries are even more obvious. If you've already gone to the 19th arrondissement, you might have passed by le Parc des Buttes-Chaumont, which is characterized by its staggering difference in elevation compared to its surroundings. And this is due to the fact that the park used to be a heavily exploited open-sky quarry up until the end of the 19th century. Eventually, as the city expanded, it enveloped the quarry, and it was later converted into a park, which is why you'll find the remnants of such a massive quarry inside of a major European city like Paris. However, in the quarry des Buttes-Chaumont, they weren't looking for limestone, but for this neat mineral called gypsum. And although you might not recognize it in its natural form, once grounded up, it can be turned into plaster, which is where we got Parisian plaster from. See, Paris is one of the rare cases where not only the building blocks could be found, but also the glue to bind these stones together, thanks to its abundance in this mineral. Gypsum would have formed after the limestone when the sea that once covered the region began to retreat and left behind isolated lagoons. Under hot evaporative conditions, gypsum crystals began to form. In fact, the hill where the Sacré Coeur now stands, Montmartre, known today for its artistic neighborhoods, was once a major gypsum quarry, active until the end of the 19th century. Its heavy exploitation left a complex network of underground galleries beneath the hill, greatly affecting the soil's stability. Before building the Sacré Coeur Basilica, engineers had to ensure that the hill could support such a massive structure. To address these risks, special measures were taken during the construction of the Sacré Coeur, and today the basilica rests on steep pillars, some reaching up to 40 meters in depth, to reach more stable rock layers and bypass the old gypsum quarries. This technique allowed the structure to stabilize despite voids left by quarrying, and today it stands as an imposing structure towering over the entire city. But the story of stone isn't just told through buildings, it's also etched into the city's very street names. Although Paris looks like this today, back in 1739 it looked more like this. It's fun to see just how much the city's landscape has changed since then, with much of what would become the Parisian suburbs still being just open countryside. Moreover, at the very center of the city, you might be familiar with Paris's two islands, l'île de la Cité and l'île Saint-Louis. But switching to our old map, we'll also see a third island called l'île Louviers, which was later filled in and attached to the right bank of the Seine. And if we look to the west, towards the modern-day Champs Élysées, switching to our old map, we can already make out the precursor of the Place de l'Étoile, today home to l'Arc de Triomphe. And what's striking is just how rural this part of Paris was at the time, dotted with fields, or champs in French, which is exactly where the renowned avenue got its name from, Champs Élysées. Now if we go to the western 18th arrondissement near the cemetery of Montmartre, we'll find the administrative neighborhood des Grandes Carrières, which literally translates into the Great Quarries. And if we go back to the past, we'll see this area was once covered in open sky quarries on the western flank of the hill of Montmartre. Now if we go to the 16th arrondissement, we'll find Rue Nicollot, which used to be called Rue des Carrières. Switching to our old map, notice how Passy Street has been left virtually unchanged. And in the placement of present-day Rue Nicollot, previously Rue des Carrières or Quarry Street, we'll find open sky quarries, literally inscribed with Carrière de Passy or Passy Quarries. But the story doesn't end there because time, weather, and pollution continue to shape these stones even today. These materials are sensitive to their environment. Over time, exposure to the elements takes its toll. Rainwater, slightly acidic from atmospheric CO2, reacts with the calcium carbonate in limestone, slowly dissolving it and eroding intricate details. This chemical weathering creates rough textures and weakens the stone over time. Sulfur dioxide from traffic and industries mix with rain to form sulfuric acid, producing gypsum crust on limestone facades. Ironically, the mineral that was once quarried now corrodes the building it helped construct. These crusts darken, trap pollutants, and eventually cause stone to flake and decay. It's not just unsightly, it can actually weaken the structural integrity of the facade. Together, these processes make maintenance a never-ending battle. That's why so many of Paris' historical buildings are regularly cleaned, consolidated, or restored. Understanding the geological foundation of Paris gives us a deeper appreciation of its architecture. Each building, each stone is a fragment of Earth's ancient past, carefully carved and placed to shape this vast living city. And this principle isn't unique to Paris. Across France, cities reflect their geology. Take the city of Clermont-Ferrand, for example, which is built near ancient volcanoes, where you'll find dark volcanic stones shaping the striking cathedral of Clermont-Ferrand. In contrast with modern architecture and standardized building materials, we often lose that intimate connection between a city and the land it was built on. That's why so many newer cities around the world tend to look alike, detached from the unique geology and identity of their region. So next time, if you happen to take a stroll through Paris, remember these stones took millions of years to form, carrying the story of ancient seas. And if you look close enough, you might even spot a few fossils, tiny fragments of the Earth's past hidden in the city's walls. So now I'm done with the script. I would like to thank you for coming to the end of this video. I should mention it's my first time making anything like this, so if my voice is off or the editing isn't great, I apologize for that in advance. If you can leave a like, a dislike, or even a comment so I can have a better idea of how the video is received, that would be great. I also left a brief introduction for myself in the description explaining my background, what I intend to do with this channel, so if you want to tag along, that would be great. Until then, I'll see you next time, bye.